Hello everyone, it's August the 8th. Let's do this. Magic squares in grid. 3x3. Magic square is a 3x3 grid filled with distinct numbers from 1 to 9 such that each row, column, and both diagonals will have the same sum. Given a row by 6. Given a row times column grid of integers, how many 3x3 contiguous magic square subgrids are there? Only contain numbers from 1 to 9. Grid may contain numbers up to 15. So if we have 15, then it's not going to work, right? We need each row, column, and diagonal have the same sum. So what we're going to do is we compute the first 3, right? And then we find the sum. Contiguous. What do you mean by contiguous magic square? So we just need to find a 3x3. Right, we just need to find a 3x3 in the whole thing. Okay, and could be 10 by 10. So we compute the rows, compute the columns. Okay, we get all of them. And then if it's not good, so we have to go through every single one to check if the first one is good. Right, and then we move forward. And moving forward, we will add 1 column, right? And then we'll update all the row sum. Well, because it's 10 by 10, I could just check. Yeah, I can just check. How bad could it be? This problem is kind of boring. Yeah, so my idea is very straightforward. So simply, what we return? The number, right? So we say private int is magic, right? Int would pass the grid and I, j, right? And we say for int si and sj, I equal to si, I smaller equal to si plus 3, right? 0, 1, 2 plus 2, I plus plus. So into rows, right? Check rows. For each row, we need to have a sum, right? Oh, yep. All right, we need to have a sum. So we can say int sum. Everything is positive, right? everything is positive and we cannot have duplicates. Okay, so sum is equal to 0. Duplicates int, not int, set. We can just say int, no, boolean, scene, nine, 10, 0, 10. Okay, then we will say check rows, current sum, sj, j is small equal to sj plus 2, current sum. Oh, if scene grid I, hold a second, I, j, right? If scene, oh, okay, couple of things. If grid ij is 0 or 50 is equal to 0, or grid ij is larger than 9, or scene grid ij is true, right? This is so we just return 0 immediately. Otherwise, scene grid ij equal to true, current sum plus equal to grid ij. Right? Then we say if sum is equal to 0, sum equal to current sum. Right? Else if sum is not equal to current sum, return 0. So let's check rows. Right? Now we'll check columns for j, sj, j small equal to sj plus 2, j plus plus, for I, si, I smaller than si plus 2, I plus plus, current sum plus equal to grid ij. Right? If sum not equal to current sum, return 0. Okay. Check diagonal. If grid si, sj plus grid si plus 1, sj plus 1 plus grid int top left to bottom right. Oh, thank you. Yeah. out the new thing again tomorrow. In 2 days.
Are you gonna sleep soon?
I'm gonna sleep soon. Friday will be tough.
Why?
I have to go to bed really early.
Why?
Then wake up at 2.
For how long?
The game? The game is 1 hour and a half. 2 hours.
Game.
It's a weightlifting. At 2 p.m. At 2 a.m.
For an hour and a half?
Yeah.
And go back to sleep?
Yeah.
Why can you sleep on the couch so you don't wake me up at 2 a.m.?
Yes. Okay. Night. Que duermas bien. Chama. Where are we? Okay. That's top left to bottom right. Top right to bottom left. I forgot something. Grid SI plus 2 is J. If TLBR not equal to sum. I'll feed them later because they just finished the other one, so I'm usually wait a little bit. Otherwise, return 1. Okay. So now we have rest equal to 0 for and I go to grid.length. One more thing. I need a scene. Need to add it together. Need to equal to 9. Int count. Oh, actually more. Yep. I is smaller than grid dot length and j smaller grid 0. J smaller than grid 0. Okay. Huh. You know what? I don't like it. I don't like it. I do not like that. I don't like it. I will do it here. Right, so 0 I smaller than m, I plus plus. Right, say if I plus 2 is smaller than m and j plus 2 is smaller than n, right? Then the rest plus equal 2 is magic. Grid at j. And then we'll return. Okay. Brute force. A40. Since the input size is small, can brute force this problem. Well, what's the runtime, do you think? Well, we have mn times 9, because here it is just 9. This is 9. I could look about right. Yeah, essentially, I don't think there's anything more to say about this one. Manual scanner, what else can you do? Oh, what is the unique property? Oh, you add them together. Divide by 3. Ah, okay. Yeah. So sum should be 15. Current sum, blah blah blah. So I just need to say this. Yeah. 1, 2, 9. Total sum is 45. Yeah, that's a good one. I try to find out what are the combinations. Jesus. Nothing to be said more about this. Okay, so this one I remember. In soldiers standing a line, each soldier is assigned a unique rating. Choose 3 soldiers. Rating go up or rating go down. Ah, choose 3. Then the ratings go up or the ratings go down. So I think we find a value, right? And we count the number of values bigger than it to the left and number of values smaller to the right. You multiply it. Or you do the other way around. Okay. So what we need to do is to find the number of it's bigger than this. Number that's bigger than this. So what are we doing? And use BIT, right? They use BIT to do this. How? What I remember is we can do a counter, right? And what we say is we need a prefix sum, right? That's what we want. Prefix sum of the values. Yeah, because if we set up a whole array, each one is just a rating. It's a counter, right? It's a counter. And then we say, find me the number of values smaller than 3, which is essentially saying, find me the prefix sum from 0 all the way to 3, not including 3, so 3 minus 1. Find me the prefix sum, right? Then that is the total. And then you can say, do me a favor, find me the sum of from right, the most right, okay, and minus, yeah, and that's okay. So we have that, which is what else do I need? I need the ones bigger than 3 to the left. Oh, how do we do that? Bigger than 3 on the left, and we want something smaller than 3 on the right. Bigger than 3 on the left. Prefix sum of everything bigger than 3 on the left. How is that solved? Well, technically, we can just reverse ratings, right? We do a reverse rating. Okay. Then bigger than 3 on the left is equivalent to bigger than 3 on the right. So we can use the same type of BIT for this. We just need to fill it up differently. Okay. Okay. So what you're saying is if we read through this, every time we find something, we we update the BIT. We updated BIT, and then we update the entire BIT left to right, and then we do the same thing, reverse, okay? And as I go through one by one, go through this one by one. See, we go through this one by one. One is going left to right, okay? But the other way has to go from right to left. It doesn't matter, right? It doesn't matter. It doesn't matter because index-wise, yeah, we can just go from this way to this, right? So one is starting from here, and then the other way will start from this, and then as we go through, right, as we go through, we're doing the same thing. Yeah, I think it will work. Because left to right, you do a counter. And then right to left, you do a counter. So once you hit something, you say, okay, in this BIT, but on the two BIT gonna be the same? No, it's now gonna be the same. Yeah, it's now gonna be the same. Okay, so we need BIT for this. I don't know how to do BIT anymore. This is BIT. Okay, let's read this code again. So what do we have? Initiate n. Size of the range. 1 based BIT. Update the value at position by adding delta. I smaller than length self bit. I plus equal to I and minus I. Oh my god. So this is similar to binary lifting. It is similar. So when you add 1, every binary wise, I'll add 1. And when you query, okay. So ratings. So we're gonna say left to right. So left to right. L left to right. BIT. M shall equal to max rating. I think that's right, because we have a max value. That was the range. Right to left is also BIT. Okay. Then we should say for I rating BIT L to R dot update R1, and for R in rating right to left. Okay. And so what we need is left small, left to right, query R minus 1. Is that right? That is actually not right. You have to build it up. That is actually not right. Because if you go left to right, yeah, you can't. You have to build it up as you're going. Hold on, let me think again. Yeah, the smaller on the left we have to build as we go through. Bigger on the right. How do we handle bigger on the right? We have the total big. Okay. We have the total big and that minus the big on the left, so the big on the right. Okay, that we can do. But how about bigger on the left? We have that? How about smaller on the right? Okay, so basically we're saying we don't do this. Just like we don't even do it here. We do it here. Okay. L small is this, right? Right big shall equal to R2L dot query bigger, right? The M is bigger because it has to be the biggest, right? It has to be the biggest. M is the biggest. So that will give you the total, right? That will give you the total. And then shall minus left to right. So I need it to be bigger, right? So left to right. It doesn't even really matter it's left to right. But yeah, it doesn't really matter because eventually it's the same. Yeah, I think it's just two BITs. BIT2 right, BIT2 this is BIT1. So BIT1 this, right? And BIT2 to this is the total smaller than that minus BIT1 BIT1 dot query this is all the ones that's it should be bigger than because it has to be on the right side, so everything on the left side that's bigger than, that's smaller than this. Okay, so this is a total, right? The total number that's bigger than that. Okay, then we'll minus right, is the total number that's bigger than r minus the total number bigger than r for the bit of 1. So that's the one on the right hand side. Okay, how about left big? Say left big should be bit1 dot query m Alright, is the left big, right small. Total minus something like this. I'm gonna run it. Very, very rough. I'm gonna try to see if this one works. Okay. Interesting. How? Huh. Six. Oh, maybe we should m plus 1. Range. But how does 6 comes in? We did a query on 6. What in the world? Oh yeah, this plus 1. Okay, so basically we need plus 1. This seems to be right. Seems to be right. Do we have some... we do have a wrong answer. And this wouldn't do it. You don't even need the BIT. I do need one BIT because I need to query. I need 1, but this one doesn't require BIT. This one is just the prefix sum. Yeah, I think 1 BIT is sufficient. Yeah, this doesn't have to be BIT. This is just pre-sum. Right, and then oof. Pre-sum. Got it. Now, might as well just do it this way. Yep, might as well just do it this way. To compute the number of elements that are smaller or bigger to the left or right of the value currently under consideration. What was this solution? I forgot. Bigger than the current, right? Count rating is bigger than if it's smaller. Then if I have more than 2, then I go through them. But I can use this as well. Yeah. Because I can just do one and then we find one smaller. Count smaller just on our left. Yeah, this is a different idea. This is if you have something that's been, if we're given a current, count bigger as 2, then we go through every single one, and each one, if we have count bigger than that, we just add those, add those. Right, we should count bigger, and then we need to count smaller. Yeah, that's actually pretty good, I have to say. All right, that will be it. I will see you guys tomorrow then. Adios.